Let's talk about 2D and 3D spaces. Now, in high school, you have already learned about the Cartesian plane that usually had x and y as its axes, with the origin here. But now, if we move into a 3D space, we add an extra axis, with x facing towards you, y facing to the left and right, and z facing upwards, indicating up or down, and origin being here. But now you'll find that there is a difference between y equals 5 here and y equals 5 here. What do I mean with this? Let's jump a bit back. We know that we have a line with all of the numbers on this line. 1, 2, 3, -1, -2, -3. This is represented by r. In this case, you can say that this is the x-axis. But now we add another axis, an axis like this, which goes 0, 1, 2, 3, -1, -2, -3. This is also represented by r. But now these are put together, so we get r squared. And if we add another axis that goes out like this, then this is also represented by r, making this r cubed. That is fine and dandy, but what does that actually mean? Let's say they give you y5 and y5, and they say, okay, draw it in the r squared plane and draw it in r cubed. What do? Well, r squared we already know. This is something that we're quite familiar with. 5 would be around here, and we would just draw a line like this. But if you draw this line over here, remember, this kind of shifts to go like this, because here is y, which is y here, and here is x, which is here. So it kind of rotates. That's how I see it when I need to draw it. Or you can just say, okay, y, 1, 2, 3, 4, 5, y5 is here, and we know that the line would go here, y5. But an interesting thing happens here. Here, we assumed that z equals 0. And here, we can't assume that unless it's stated. Z equals to k, where k is an element of r. What does this imply? What is this of importance when you draw the sketch? Well, an interesting thing happens. So, imagine this line is a wall. A very, very thin, low wall. K represents a constant, meaning that we start at, let's say, z equals 0. This is z equals 0, right? Then we start at z equals 0, 0001, 002, 003, and we just keep adding lines on top, and we go on like this infinitely many times. What will happen is we'll build a wall, right? And this wall, which is stacked out of a bunch of these lines, is a plane. And this plane goes downwards as well. So it goes into the negative z's and into the positive z's, creating a plane or a wall. Now this is a very interesting concept, and you would wonder, okay, but if this has infinitely many lines, doesn't this have infinitely many dots? And that is correct. We assume this to be a line, but in reality, this is a bunch of dots. Having x equal to 0, equal to 0, 00001, 002, and it just goes on infinitely many times, creating a line because there are infinitely many dots. The same concept applies here. But now, another interesting thing happens. Let's say we have our axes, and they give us a circle with radius 1. The equation for a circle is x squared plus y squared equals r squared. So x squared plus y squared equals 1 in this case. So what do we do in this case? Oh, it's the same thing. Remember when I said we rotate it to draw it here, or if it's just easier for you, you just count and then you draw it? Same thing applies. Remember, it's like taking a sheet of paper and laying it down flat on a table. So we'll have a circle that looks like this. Okay, this looks more like an oval, but it gives you the idea. Remember that I said that it's a bunch of lines stacked on top of each other? Well, in this case, it's a bunch of circles stacked on each other. But it's also important to note that this says equals to 1. So if this were to say x2 plus y2 smaller than and equal to 1, then this circle over here the inside would be included. But in this case, it's merely the outside of that circle that is being referred to, not the inside. So if we go to here, it's basically like, you remember the loom bands or hair bands? It's like a bunch of them stacked on top of each other, infinitely many times in the positive and negative direction. And what does this form? It forms a hollow cylinder. So here is the wall of the cylinder, completely hollow, going downwards.